Hello everyone, this is Divya working as assistant professor in EEE department at St. Peter's Engineering College. So today in this lecture we will see how to locate poles and zeros on S-plane. Those are the real poles and imaginary poles also we can locate on S-plane. So to discuss this we will see the problems. That means by using the transfer function we have to obtain both the poles and zeros and we have to locate it on the S-plane. Okay. So for discussing this one, I am sharing a PPT with you. So here in the transfer function is given as s plus 2 divided by s into s square plus 2s plus 2 into s square plus 7s plus 12. So for this transfer function, we have to determine the poles, zeros, pole zero plot and characteristic equation. So first of all, what is the procedure to determine the poles of the particular equation? That is, we have to equate the denominator of the transfer function to 0. So by equating the denominator of this particular transfer function, what will be the equation? That is s into s square plus 2s plus 2 into s square plus 7s plus 12 is equal to 0. So therefore, s can be taken as s plus 0. That means s is equal to 0. And we can write this s square plus 7s plus 12 as s plus 3 into s plus 4. Why? Because if you multiply the s plus 3 and s plus 4, the resultant is equal to s square plus 7s plus 12. So you can consider s plus 3 is equal to 0 and s plus 4 equal to 0 like this. So from this we can obtain s is equal to minus 3 and s is equal to minus 4, right? So these are the poles of the given transfer function, and we have another two more poles by considering this equation, that is s square plus 2s plus 2. We have to consider this equation separately and we have to determine the roots of the equation. So let us see what are the roots of the equation. That is nothing but, so we have to consider s square plus 2s plus 2 is equal to 0. These are not having real roots. That's why I'm determining the roots by using the formula minus b plus or minus root b square minus 4ac by 2a. So from this one I can obtain the roots as minus 1 plus or minus j. So here I can say it as the root 4. That means the pole number 4 is minus 1 plus j and the root pole number 5 is minus 1 minus j. That means these can be called as complex conjugate poles also. That is minus 1 plus or minus j is a complex conjugate pole. And coming to zeros, we can obtain the zeros by equating the numerator with 0 value. That means here in the problem they given s plus 2 as the numerator. So the zeros can be obtained by equating the numerator with 0. So I can take it as s plus 2 is equal to 0, right? So here we can obtain it as s is equal to minus 2. So what is the 0 here? The 0 value is minus 2 and the poles values are 0, minus 3, minus 4, minus 1 plus j and minus 1 minus j. So these are the poles and zeros determination. And coming to what is our third aim, we have to represent these poles and zeros on the S-plane. That is nothing but pole zero plot. So we have to draw the pole zero plot. For drawing this pole zero plot, you have to consider a graph sheet. So you have to draw the S-plane on that graph sheet. You have to represent the S-plane on that graph sheet. That means you have to partition that graph sheet into four quadrants like x-axis and y-axis. You have to consider sigma and j omega axis. Sigma is the real axis and j omega is the imaginary axis. So in the place of x, you have to consider sigma, and in the place of minus x, you have to replace it with minus sigma. And in the place of y, you have to replace it with j omega, and the minus y-axis can be replaced with minus j omega. Already in the last classes you seen how to represent the real values and imaginary values as in S-plane, and also how to represent the scale of the S-plane. So that one you know earlier, right? So here what I am doing is, here I obtained the poles values and zeros values. I have to represent these poles and zeros on the S-plane. So here I consider S-plane having the sigma axis and j omega axis. This is the real axis and this is the imaginary axis, right? So here on the real axis and imaginary axis also I considered the values like this. with a period of 1 unit. So here what I done initially, I represented all the poles. What is the first pole value? That is 0, right? And after that, what is the second pole value? That is -3. What is the third pole? That is -4. All the poles must be represented with a cross mark, right? So here I represented all the poles with a cross mark. And coming to the other poles, what are the two other poles? That is -1 plus or minus j. Initially, I am considering -1 plus j. -1 is a real part and j is a complex part, right? So here what we have to do? We have to see the -1 term exists at which position. So here this is the -1 axis, right? So on the -1 axis, project the value to j. That means the imaginary part is j. So draw a line from j to -1 axis like this. So here this is the interaction point of the -1 axis and j axis, right? So this is our required pole, that is -1 plus j representation. And coming to -1 minus j, what we have to consider? On the same line we have to project minus j axis. So here this is the contact point of the -1 axis and minus j axis. So this point is represented with a cross symbol. That means this is the fifth pole. The fifth pole value here you have to show it as -1 minus j. So this is the representation of poles on the S plane. Then what you have to do? We have to consider the zero value on the S plane. Here how many zeros exist in the given control system transfer function? Here in the given control system transfer function, there exists only one zero, that is s is equal to -2, right? So here I represented s is equal to -2 on the left hand side of the sigma axis. That means at minus sigma axis, this is nothing but the zero. So zero means we have to represent it with a circle or with a filled circle. So I can represent like this, or else I can represent with only one circle. So till now we completed the obtaining of poles, that means the determination of poles, the determination of zeros, and the representation of poles and zeros on the S plane. Then what is our fourth aim in the problem? They ask to determine the characteristic equation also, right? So here I have to determine the characteristic equation. To determine the characteristic equation, I have to equate the denominator of the transfer function with 0, right? So here what is the denominator of the transfer function? That is s into s square plus 2s plus 2 into s square plus 7s plus 12, right? So I have to equate this transfer function with 0. So by equating this transfer function with 0, I can simplify this equation as shown here. So here I am multiplying the s with directly this first term. So it can become s cube plus 2s square plus 2s into s square plus 7s plus 12 is equal to 0. So by multiplying these two terms again, I will get a larger equation like this in terms of s domain. So by simplifying this equation, finally I am obtaining the equation as s power 5 plus 9s4 s power 4 plus 28 s cube plus 38 s square plus 24 s is equal to 0, right? So this is the final characteristic equation for the given transfer function equation. So by using this characteristic equation, we can obtain the performance of the system. That's why we have to determine the characteristic equation. So here in the question also, they ask to determine the characteristic equation. What we determine now? We determine how, what are the poles existing for the given transfer function and what are the zeros existing for the given transfer function, and we represented both the poles and zeros on the S plane, and also we determined the characteristic equation, right? And coming to the next problem, here we will see another problem. So here also they given a transfer function which is nothing but s plus 2 divided by s into s plus 4 into s square plus 6s plus 25, right? So here what is the degree of the denominator? That is s power 4, because s into s square into s square is nothing but s power 4. So how many poles exist for the given transfer function equation? There exist 4 number of poles. What is the first pole here? How we can determine the poles? Again we have to equate the denominator with 0, right? So by equating this denominator with 0, we can obtain s is equal to 0. Why? Because here there exists only s term. So I can write it as s is equal to 0 directly. And by considering the second term, that is s plus 4, I can write it as s is equal to -4. So here till now we obtain two poles, that is 0 and -4. After that one, I have to obtain the roots for this particular term, that is s square plus 6s plus 25. So for obtaining the roots for particular term s square plus 6s plus 25, I have to consider that term must be equal to 0. So by considering the term equal to 0, directly I am unable to determine the values by using the splitting method. So I am going with the formula method, which is nothing but to determine the roots. What is the formula? Minus b plus or minus root b square minus 4ac by 2a. So by using this formula, if I am substituting the b value as 6 and a value as 1 and c value as 25, I can obtain the s values as minus 3 plus or minus j4. That means the one of the pole is minus 3 plus j4 and the other pole is minus 3 minus j4. So here earlier we already obtained two poles which are nothing but 0 and minus 4. So with this pole there exists total 4 poles. That means 0, minus 4, minus 3 plus j4 and minus 3 minus j4. These are the total 4 poles here there exists for the given transfer function. And coming to the second one, what is our second aim? We have to determine the zeros of the given transfer function. So to determine the zeros of the given transfer function, what we have to do? We have to equate the numerator of the transfer function with 0. So here what is the numerator? That is s plus 2, right? So s plus 2 is equal to 0 we have to take. So to obtain the zeros, here I considered s plus 2 is equal to 0. So it implies s is equal to minus 2. That means the 0 of the pole is s is equal to minus 2, right? So this is the 0 of the given transfer function. And coming to the s-plane representation, that means pole 0 representation, we have to consider all the poles and zeros. That means we have to represent all the poles and zeros on the s-plane, right? So what I done here, again I consider the s-plane, that means the sigma axis and j omega axis. We have to represent all the real values and all the imaginary values. So here initially I am representing the poles on the S plane. So here what are the poles we obtained? Those are 0, minus 4, minus 3 plus j4 and minus 3 minus j4, right? So here I represented 0. And the second one is minus 4. The 0 and minus 4 both are represented with a cross mark, right? And what is the third one? That is minus 3 plus j4. So this is the minus 3 axis. On this axis the y value is 0. That means j omega value is 0. But here in the pole which we obtained, the value is minus 3 plus j4. So that's why what I am doing at minus 3 only, I am drawing the projections like this in parallel to j omega axis, and from j omega axis, from where the 4j exists, from that line I am drawing the projections onto the minus 3 axis. So this contact point represents the pole, that is minus 3 plus j4. In the same way, on the opposite side also, that is the complex conjugate root minus 3 minus 4j I am representing here. For that purpose, what I am doing here, at minus 3 I am drawing the projection in parallel with the j omega axis, that is minus j omega axis. And from minus 4j also we have to draw a projection line in parallel with the minus sigma axis, so that the contact point of those two projections represents the pole minus 3 minus 4j. Okay, so here this minus 3 plus 4j and minus 3 minus 4j should be represented with a cross mark, because all these four crosses indicates the poles on the S plane, that means poles of the transfer function. And coming to zero representation, here there exists only one zero. That means we obtained it as minus 2. So at minus 2 only I have to represent the minus 2 with a circle, that means with a empty circle or else with a filled circle like this. So this is the representation of poles and zeros on the S plane. And coming to next one, that is we have to obtain the characteristic equation for this particular transfer function. So how we can obtain the characteristic equation? To obtain the characteristic equation, we have to equate the denominator of the transfer function to 0, right? So for that reason, here I am taking s into s plus 4 into s square plus 6s plus 25 is equal to 0. So here I consider that equation, and by simplifying this equation, like by multiplying s into s plus 4, I obtain s square plus 4s into s square plus 6s plus 25. By multiplying these two terms, here I am getting s power 4 plus 6s cube plus 25s square plus 4s cube plus 24s square plus 100s is equal to 0. By simplifying this equation, I can obtain it as s power 4 plus 10s cube plus 49s square plus 100s is equal to 0. So this is the characteristic equation for the given transfer function. So in the example 5, what we discussed here, we obtained the poles, zeros, and we located the poles and zeros on the S-plane, and we determined the characteristic equation also. So here in both the example, there exists an imaginary pole. That means there exist two imaginary poles. Those two are again the complex conjugate poles. What is meant by complex conjugate pole again? So the poles which are in the form of A plus or minus IB, those poles are called as complex conjugate poles. Here there exists A plus IB. That means in the first case there exists minus 1 minus 1 plus j and minus 1 minus j are the poles. So those are the complex conjugate poles. Coming to the next problem, there exist minus 3 plus 4j and minus 3 minus 4j are the imaginary terms. That means complex conjugate numbers. Okay. So this is about determination of poles, zeros, and location of poles and zeros. That means location of the imaginary poles on the S-plane. In the previous problems, we seen the location of the poles which are real only. We didn't see how to locate the imaginary poles on the S-plane. So here with this video, it is clear how to locate the imaginary poles on the S-plane and how to determine the characteristic equation of the transfer function. Right? Thank you.